Welcome back to part 2 of grade 10 geometry. Today we are dealing with a kite, quadrilateral kite. So what happens with the kite? Here we've got line AD and we've got line AB, and we are told that these lines are equal. So line AD is equals to line BD, and then we've got line BC and line DC. These two lines are equal as well. But line BC and DC, observe, they are not equal to line AD and AB. So we write here that we have got AB, which is equals to AD, and we have got BC, which is equal to DC. That's where we start off. Now, from there, we have got this angle D here. So we are going to use a different marker to highlight the angles. Angle D here is equal to angle B. So we now say that angle B is equal to angle D. So you must note that these two angles, opposite angles of a kite, are equal. Alright, from there, what are we going to do? Now we're going to draw a diagonal line which we shall call AC here. My diagonal line is not that straight, please forgive me for that. Now, so we now AC is a diagonal line. Now, through this whole process of it being a diagonal line, what did it do? It now bisected angle A, and it also bisected angle C. So we say AC bisects angle A and angle C, meaning to say that here on angle A, I'm now giving you these markings and call this A1, this is A2. Then on angle C, I now show you these other markings. So this one I call angle C1, and that is angle C2. Why did I color them differently? Because I'm trying to tell you that angle A is not equal to angle C. However, angle D is equal to angle B. Now observe two triangles have been formed here. We now have triangle ADC and triangle ABC. So if I'm to draw this triangle ADC on the side, right? If I'm to draw it, it would look something like this. So we would say this is point A, D, and C. And then if I'm to draw triangle ABC, it would look like this. Okay, so this is A, B, and C. Now I'm going to repeat the markings. You can see them here, they're close by. That. Okay, and then one marking is left, or two markings. This angle is equal to that angle, and we now speak about the fact that this angle C and that angle C, this is angle C2, this is angle A1, and we have that marking and this marking. This is A1 and that is A2. So now what happens? Remember, they can ask you to prove that from this kite, but they will be identifying triangles. Then they'll say prove that triangle ADC is congruent to triangle ABC. So what do I observe? Alright, this angle is equal to that angle, this angle is equal to that angle, this angle is equal to that angle, but this is equiangular. We are not trying to prove similarity. So what do I say? I will say this: angle D is equals to angle B. So I say angle D is equal to angle B. And then they want a reason. Why am I saying that? Then I say opposite angles of a kite. That's reason number one. Number two, what do I talk about? Now I'm going to talk about angle A1 being equal to angle A2. So I say angle A1 is equal to angle A2, right? And what will be the reason? I can say that it is given because it has been marked, or I can say angles bisected by a diagonal line right? Angles which have been bisected by a diagonal line, they are what? They're equal. Then my third reason, here observe I've got line AC, there I've got line AC. So I come here and I say AC is equals to AC, which means that I've got a common side. So the first reason, angle. Second reason, angle. So I say angle, angle. The last reason was a side. Angle, angle, side. So therefore, I can conclude that triangle ADC is congruent to triangle ABC. And just like that, I would have answered, right? Okay. So not only do we find a kite, within a kite we can identify triangles. And by the way, angle, angle, side is not the only reason which I could have used. I could have used other reasons as well. Observe, line AD, it's given a marking, and line AB, these two sides are equal. So I could have said AB is equals to AD, and line DC is equals to line BC. So I could have said DC is equal to BC, and line AC is a common side. AC is equals to AC, a common side. So I could have used the side, side, side to prove congruency. That's why you have got four conditions, right? You could use them. For as long as you can prove them, then you can use them, right? I could have used angle, side, side. So I could have used that angle C1 here is equals to angle C2, and side CD is equals to side CB, and side DA is equals to BA. Do you see? Angle, side, side. Angle, side, side. So I could have used those reasons. So in trigonometry, in geometry, sorry, you can have more than one answer. You can have more than one answer to the same question. All right. So I think we're done with the diagonal line AC. Now we're going to talk about what? We're going to talk about diagonal line DB. So we're going to draw diagonal line DB here. When we draw diagonal line DB, now what do we create? Diagonal line DB, it bisects angle D and angle B. So we say DB is a diagonal line such that it bisects angle B and angle D. So because they've been bisected, we are now going to talk about the fact that here we have got angle D1, here we've got angle D2, here we've got angle B2, and there we've got angle B1, right? Okay, so that's what's happening with the introduction of this diagonal line DB. So we are now saying that Angle D1 here, which is found on the upper side, it is equals to angle B1. Angle D1 is equals to angle B1. And angle D2 here is equals to angle B2. Angle D2 is equal to angle B2. And what I've written here about those angles, I'm going to prove it in a moment that what I've written is actually true. Why? Because I'm also going to draw, if you observe line DB here, this diagonal line, when it bisected the angles, we are now having triangle ABD, and also we have got triangle BCD. So now we have to draw these two triangles, and then we talk about the properties which are found on both of these triangles. So let me just erase on the side and then draw separately those two triangles, and then we talk about the features. So I'll draw triangle ABD first. Oh God, help me. What's happening? What's happening? What's happening? It seems like I'm failing to draw the right side of triangle ABD. So this is B, this is A, and that is D. Alright, the markings, line AD is equals to line AB. Alright, and then here we've got this angle and that angle. Alright, what I'm not going to do, I'm not going to include this line here, whereby, remember, where diagonal line DB and AC are meeting, where these two diagonal lines are meeting, this is what we call a midpoint. Actually it's point E. Yes, it's a midpoint for line DB. I'm not going to draw that, and then from there I'm going to draw the second part of the triangle DBC. So we have got B, we have C, and we have D. This one had two markings there, and then we have got D2 and B2. So that's what we're going to talk about. Alright, as you can see in triangle ADB, what's happening here, we've got these markings, and alright, we've got these markings here on line AD and line AB. These markings, they tell us to say that these two sides are equal. But if we're having a triangle, when you've got two sides which are equal, it means that the two opposite angles are equal. Meaning to say this angle D1 and angle B1, they are equal. Remember, that's why I wrote that angle D1 is equals to angle B1, because I'm having an isosceles triangle, right? Alright, and then if I come to triangle BCD here, it's marked that line BC is equals to line DC, which means also this is an isosceles triangle, so angle B2 and angle D2, they are equal. Hence I wrote that angle D2 is equals to angle B2. So basically a kite is a combination of two unequal isosceles triangles. That's what's happening there, right? Now let's get back to our diagram. Now here on point E here, what's happening? The distance from line D, from point D to point E, it is equal to from point B to point E. So we're saying that here, this side is equal to that side. Remember, my diagram is not drawn to scale, so it may not look like they are equal, but in reality, this and that, they are equal. So we now say angle line DE is equal to line BE. And not only are they equal, these two lines, AC is perpendicular to line DB. So we say line AC is perpendicular to line DB. And what do we know about perpendicular lines? We know that perpendicular lines create 90 degrees. In other words, here we've got angle 90, there it means 90, 90 and 90. So if this is E1, this is E2, E3 and E4. So now we say angle E1 is equal to angle E2, which is equal to angle E3, which is also equal to angle E4, and all of them are equal to 90 degrees. And the reason is because AC and line DB, they are perpendicular. This symbol means perpendicular. So yes, now these are the properties of a kite and some of the features or some of the shapes which are found within a kite. Alright, so this is the end of our lesson. On the next video, I'm going to be talking about a trapezium. So please do join me on the next video where we talk about trapezium and its features. If you found this video to be helpful, please consider subscribing if you haven't subscribed. Share with the people that you love and care for. Comment and like the video. Till we meet next time. Cheers.